Today's topic is nested if statements from chapter 7. This is the wrong version of PowerPoint. Okay, let's pick up with slide number 3. Now inside a then statement, then part, or an else part, you can have any type of statement, including if then else or while statements, etc. So let's take an example. Suppose you have to read 3 numbers and print the largest of the 3. Okay, so it'll be difficult to do this with just one if then else statement. I don't think it's even possible. So this is a pseudocode, and let's examine the important parts of it. Suppose we read in N1, N2, N3. Now probably use better identifiers than N1, N2, N3. So up to this point we have input only. Once we have the 3 numbers, if N1 is greater than N2, then you need to do another comparison between this end and if and end if. So if N1 is also greater than N3, then what does it mean? N1 must be the largest, right? So you print that out. It doesn't matter if you have a plus or a comma here, it's just pseudocode. Otherwise, what's the situation? You know that N1 is larger than N2, so N2 is definitely ruled out, right? So do you think N3 should be the largest here? Yes, because it's not, this is false, so N1 is not the largest, so N3 must be the largest. Okay. Otherwise, compare N2 with N3 and similarly print out either N2 or N3 depending on which is the largest. So this is a pseudocode. Hope you understand it. Are there any questions on it? We are duplicating a little bit. Print N3 appears twice here, right? But I don't think that can be avoided. Something has to be duplicated. Okay, so the flowchart for this is similar. You read the first 3 numbers, assuming there are prompts for the 3 numbers, and then test if N1 is greater than N2. If that's true, make the other test. And if that's true also, that's the largest number. N1 is the largest. Otherwise, print N3. Because you know it's going to be either N1 or N3 that's the largest here, right? By the time you get here. N2 is definitely ruled out. But here, N2 could be the largest, so you compare it with N3 and print appropriately N2 or N3. And in all cases, you join together and stop. Do you have any questions on the pseudocode? Okay. You have to check this out carefully. And of course, you have to take sample data. For example, N1 equals 10, N2 equals 25, N3 equals 5. So it should print out 25, right? N2 in this case. So please note the first test, N1 greater than N2 is false, right? So you have to compare these two. Is N2 greater than N3? Yes, it is. So you print out 25. Okay, that's called a trace. And to check out all the 4 branches, you got to have 4 possibilities, right? At least. Although N1, N2, and N3 actually there could be 6 or more, so check that carefully. For sample data 2, N3 is the largest now. So you have to trace through the flowchart and make sure that 18 gets printed out, okay? So the main part is actually the Python code. So here you read in 3 numbers and convert them to integers, so you can compare them properly. Otherwise they'll be compared as strings, right? You could have names, for example, and that could be another problem. Yes, I violated one of our own rules. Camel notation N1, N2, N3, they should be all lowercase, and actually you should be more descriptive. Perhaps the first number, second number, but that defeats the purpose anyway. So please note the specific points here are related to Python are, there's a colon here, no then, and this else matches this if. It's indented accordingly. This else matches this if, and they both have a colon after them. So this else must go with this if, right? Indentation makes a big difference in Python. If you do not indent properly, it may not do what you want it to do. Any questions on this? Of course, you got to run this several times to make sure it's correct. But actually, there's a theory of computation where you can prove that something like this is correct or incorrect. And we are definitely not going to get involved in the math. It can be fairly complex. Okay. So let's take another example. Suppose you read in a score, a single score, from 0 to 100. So depending on what the score is, you want to print A, B, C, D, or F. And these are the conditions. Let's take one of them. If it's greater than or equal to 80, but strictly less than 90, not equal to 90. Because 90 would be A, right? So that would be a B, etc. And we are talking of integers only, whole numbers. So you have to create the 3 things, the pseudocode, flowchart, and the Python program. So this is the pseudocode. Now, we are probably not following the indentation strictly because pseudocode doesn't enforce that. And you have an end if, single end if for this if. Anyway, let's start here. After reading the score, if it's less than 60, you know it's an F, right? But if it's less than 70, greater than or equal to 60, must be a D, and so on. Of course, if it happens to be 105 or something, then it's assigned Z because you want to print out error over here. We should have checked for less than 0 also, right? And assign that value as Z here. Anyway, let's not worry about that error. So once we are done with this much, if grade is a Z, we'll print error. Otherwise, we'll print the actual grade, which is one of these 5 values. Any questions on that? Okay. And the flowchart becomes more complex in this case, but it matches the pseudocode exactly. So if scores less than 60, you know the person has an F. You come here and print the grade here. If it is, say, 65, then you know it's a D. Come out and print the grade here, etc. So if it's at all assigned as Z, there's something wrong with that grade, and you would print error. And this flowchart also has that same shortcoming. It does not check for less than 0. Okay. The important point in Python is demonstrated here. There's something called an elif, which is correspondingly else part of this if, and that itself has an else part, etc. So this matches the pseudocode or the flowchart. Okay, so if scores strictly less than 60, then you assign F. Otherwise, you make this test. Please note there's a colon here, and then you assign B and keep going. In the last case, actually I would have liked to see this on the next line, but it probably works. I haven't tried it recently. So if grade is assigned Z, then you print error. Please note the two equals here for equality. This is an assignment, whereas this is grade equal to Z. Okay. So this is the trace. If you enter 75, it prints the C. Do you have any questions on this? Now, this should be in the code samples. If it is not, you can cut and paste it from the slide and run it in Python. Okay? And test it out for various cases. Okay. Now we are coming to a statement which we don't have in Python. It's a cleaner statement. We use it in pseudocode or flowcharts, but Python doesn't seem to have it. There are other languages which do have something like a case statement, C++, for example. So in pseudocode, the general idea is you write case of an expression or a variable over here. Now if it happens to be equal to value 1, you do statement 1. Break means get out of the case statement. Otherwise, it'll go on to the next and so on. Now that's a thing in C++ which is left over. So don't worry about the break, but you can also assume that you do one of these and then you come out. Now if you don't do any of the cases up to default, you'll do the default statement. Okay? So we'll take an example of this in just a minute. But essentially you're checking for multiple else's, multiple cases. Okay, in flowchart form it's written like this, variable, but please note we don't have equal or anything like that. So if the value of the variable happens to be value 1, you do this statement. If it happens to be equal to value 2, you do this statement, and so on. You have to just list all the cases. It can be generalized. It could be less than equal to value 1, for example. Okay? Don't worry about that. I will not ask you much about the case statement on the test. In pseudocode, isn't this a little bit cleaner than the nested else's that we saw earlier? Case of grade, which you have read before. The problem is different now. If you read in a letter grade, you're going to print out excellent if it's an A. If it's a B, you print out this, and so on. And please note the break here, which is not needed because it won't be any of the others, right? But if you don't want to hit the default and print out incorrect grade after that. So we don't have a corresponding Python program. You can always write it with if and elifs, okay? Any good programming language should be able to do almost anything that you want to do, perhaps except graphics or sound or video or some of those. In flowchart form, you just have a question mark after grade. Is it an A? Is it a B? Is it a C? Etc. And if it's none of these, by the way, you do the case statement of flowchart left to right. Okay? Any questions on this? Okay. Now this is a more complex example. Suppose I enter, like a calculator, 7, 5, A. This is my input. I have two numbers and an operation. The output should be 12. This A is for addition. If I enter 7, 5, S for subtraction, you do 7 minus 5 and the output should be 2. So this is a small calculator without graphics, and these codes are explained here. M is for multiplication, D is for division. percent for remainder or mod. And we are also assuming we have two integers, not real numbers. It takes a lot of effort to generalize it to become a true calculator. Okay. So we have to write the pseudocode, flowchart, and perhaps the Python program. Let's see if that's done. I don't know if it is. We'll see in a minute. So doesn't this look cleaner using a case? You get the first number, get the second number, and read the operation, which is A for addition. This is an alphabet, right? And if it happens to be capital A, then the answer would be this, and you print it. The reason we have print answer duplicated for each of these is we don't want to print answer for the default, so we can't use it here, common to all of these, okay? Because there is no answer for this case. So this turns out to be very simple. All you have is plus, minus for subtraction, multiplication symbol for m, division, and so on. Any questions on this? Now we have left a few things unspecified. For example, is this integer division, or is it real? Is it going to give you a real answer? But that's something you can worry about in the programming part. Okay. And the flowchart is also fairly clear. You read the two numbers, read the operation in that order, and if it happens to be an addition or a subtraction, you do the corresponding operation, print the answer, and stop. But if the operation happens to be X or something, then you go through the default and print error. Okay? Any questions on that? Okay. So we did not write the Python program, and it would be a good exercise if you did yourself. Let's see if there are, so this says Python does not have a case statement. I can look in code samples and see if there's nested if statements anywhere to worry about. Otherwise, you can run it yourself. See if then else, nested fors and loops, but don't see nested if statements. But it's something that you can try out very easily. Oh, compare-three-numbers has it. So edit with idle. Let's see. It's come up in an older version of Python, but for this simple case it works. See, you read the first number, convert to an integer from the string, and so on. This has been done a little differently to remove the duplication, because we have studied Boolean operations. You're checking to see both if n1 is greater than n2 and it's greater than n3. If that's true, then of course n1 is the largest, right? What remains is comparing n2 with n3. And if this is true, you print n2, otherwise you print n3. I probably should have shown you an example in structured flowcharts. I think there are some examples. Nested if statements can be written like this. For this case, you would write n1 greater than n2 and something to indicate that n1 is greater than n3. If yes, print n1. If not, make another test. So structured flowcharts are a bit easier to understand than standard flowcharts. Here you have to test n2 greater than n3. And in this case, you'll print n2. You'll print n3 here. Okay? Do you have any questions? Of course, if we did not have the AND operation available, going back to the previous example, we had done it without and, it would look more like this. One if inside another. So you would need 3 if statements, right? Like we did in the pseudocode. Any questions on that? Here we need only 2. Okay, I'm going to stop here and help you with the assignments. If you have any questions. I do have some homework to return.